Well, Unit 10, you will remember, introduced part of the system of natural deduction. We concentrated there on the rules of inference. In Unit 11, we beef up the system by introducing and using the rules of replacement. Rules of replacement are a little different from rules of inference because what they allow us to do is to write a new line which is equivalent to a line that we already have inferred in a natural deduction, whereas an inference rule allows you to generate a new line in the sense of a line which is not equivalent to anything previous. With the 10 rules of replacement, the system becomes considerably more powerful, and natural deductions then turn out to be a combination of use of the rules of inference and the replacement rules. But the style of the unit is going to be very similar to the style of Unit 10. You will have problems and justifications to give, and we will finish the unit with an English argument that you translate and then do the deduction upon. So we begin with a number of problems where we are allowed to use all the rules of inference. The two strategies that you're about to learn in the last two units of the course, conditional proof and indirect proof, are not yet available. So here we start with a relatively simple problem. Now notice here the conclusion has a tilde operating on the entire disjunction. This makes it rather difficult to get clear what kind of information you really want to be looking for. It's a little bit easier to apply one of the replacement rules straight off to the conclusion. Do this in your mind or on the side and say, if I use De Morgan's rule, I know that the conclusion is equivalent to not B and not D. And by doing that, you now see that to solve the problem, you need to infer not B and also to get not D. This helps, of course, because we already have not B as one of the premises. So now the problem becomes simpler. If I can find not D, I can simply then add it, I can join it to not B, get a line that looks like this, and then with De Morgan's rule, generate the conclusion. So now the question is, can I derive not D? And I look at the premises and see it occurs only in line 2 as the consequent of a conditional. And so I'm going to have to do something probably to get the antecedent of this conditional, A or C, in order to use modus ponens on line 2 to get the not D. So we need to find A or C as another intermediate goal sentence to solve the problem. Line 1 is the only place where A occurs again, and so we know we're going to have to manipulate line 1 in order to give us A or C. Well, now, two moves are going to have to be made on line 1 to put it into some kind of shape so that we can infer A or C. We're going to, in a sense, have to get rid of the B somehow. We do this with a move of commutivity, which allows us to take the B and invert its position with the A, and then a move of associativity, which will allow us to bracket the A and the C together, which is what we're hunting for, and to, in effect, isolate the B outside. Let me show you what I mean. The first move will be to change the position of B or A in comparison to line 1. And this is simply justified by the replacement rule commutivity. Notice the order of the disjunctions doesn't make a difference, so line 4 is equivalent to line 1. Now we need to do the associativity move on line 4, and this is in effect a move that permits you to change the position of the bracketed or parenthetical unit here. We, in a sense, move the parentheses over so that they now encompass A or C. And remember, you can only do this on a line where you have a repetition of the same connective, either the disjunction twice or the conjunction twice, no mixture of those two connectives. And so that gives us B on the outside of the parentheses, or A or C. It's just like mathematics rule of associativity. And we cite line 4, associativity. Now this helps, of course, because we have not B in line 3. So disjunctive syllogism on 3 and 5 will give us A or C. And remember, that was one of our intermediate goal sentences. That helps because that allows us to generate not D by modus ponens on line 2. So we get not D, and we cite 2 and 6 modus ponens. Now we have not B there and not D here. We simply conjoin them together, citing 3 and 7. And this is equivalent to the answer by De Morgan's rule. So De Morgan's rule allows us to, in a sense, pull the tilde outside of a set of parentheses, and when we do that we need to interchange the connective, flip the connective as it were, from an and to an or vice versa, and so that gives us B or D. And we just cite line 8, De Morgan. So notice now, unlike Unit 10, this problem involves a combination of lines, some of which have used a replacement rule, some of which have used an inference rule. Here we have a replacement rule, but these two are inference rules. This is an inference rule. This is a replacement rule. Okay, so let's do another. Here we're looking for not E. We know by examining the premises that we're going to have to get the not E out of this part of line 1. It's the only place the E occurs. But we have two tildes here in these premises operating on the whole complex sentence that comes after them. And so once more, it's difficult to see exactly what information is being given to us in 1 and 2. The best thing then to do is to clarify that by relying upon the replacement rule of De Morgan. De Morgan's rule, remember, allows us to either pull out or drive in the tildes in through the parentheses. So let us replace lines 1 and 2 with two lines that are a little bit more conspicuous. This is a conjunction, and so De Morgan's rule tells us that we bring the tilde inside. That will then operate on the first conjunct there. We have not F here. And then we need to change the connective to a disjunction and negate the other component, which is the not G. So we end up with not parentheses E and not F, or not G. That's from line 1 in De Morgan's rule. Now that itself is not, again, particularly clear, so why don't we do De Morgan once more on the E and not F, getting rid of this tilde that's operating on the outside, in a sense. So we do that, of course, by generating not E or not F. And all of that is in parentheses. Or not G. That is 3 De Morgan. Now we can clean line 4 up a little bit by getting rid of the two double negations with the rule double negation. So we end up with not E or F or G. Now how is this going to help us? Well, let's manipulate line 2 a little bit, and we'll see then that it'll become clear how 2 and 5 relate. Do the same thing. We'll use De Morgan's rule on line 2 this time, and we'll get not F and not G. And that is line 2, De Morgan. That means we have both not F and not G to work with. We can easily simplify line 6. And remember now, we're going for not E. Well, notice that 5 is now in a position to allow us to see that two moves of disjunctive syllogism that employ the two parts of line 6 will allow us to actually get in here and get what we want. Here's how that works. We simplify and get not F and also get not G. Both of those come from line 6. Oops, 6, simplification. And now notice the not G negates this disjunct of line 5. So disjunctive syllogism tells us that we must know not E or F to be true. And that requires line 5 and line 8, disjunctive syllogism. And now recall we're looking for not E as the answer, and not F, line 7, negates this disjunct, so the second move of disjunctive syllogism leaves us with not E, and we cite line 7 and line 9, disjunctive syllogism. Okay, so that was a good problem because it shows that though the information can be there in the premises, sometimes it's not so clear what it is. It can be obscured by the structure of the premises, and this is what the replacement rules are there to help you see. They clarify what the information is in the lines that we have to work with. All right, now we'll do a couple of more similar problems. Here we have not E again as our goal sentence, as our conclusion. And we look at the premises, we realize it is certainly going to come out of line 3. We could get not E out of line 3 if we could do 2 modus ponens moves. If we had S, in other words, we would then be able to get a line that looked like this. And then if we had all of this antecedent material, we would be able to get not E. So that's a plausible strategy. The big thing, of course, will be, can we get all of this antecedent material? And once more, it's hard to see if we can or not because of all of these tildes. So we have to take advantage of De Morgan once more and see what that material in 3 amounts to. Notice we have the S here, so let's do the first modus ponens move on line 3 to eliminate the S. We need S first from line 1, simplification. That gives us not, parentheses, not I, and not D. When you do this, always be careful. It's easy to get the tildes in the wrong place. So go slowly and make sure you don't drop a tilde or put it where it doesn't belong. This is, of course, line 3 and 4, modus ponens. And now we're at that point where we can't quite see what all of this amounts to. So we want to do the De Morgan step, giving us not I, or not D in parentheses, and all of that hooks not E. And so we cite line 5 and De Morgan. Okay, once more, like the last problem we did, we still have a little bit of unclarity because of the double negations, so let's eliminate those, and we've got I or D hooks not E by line 6 and double negation. Okay, now we need to generate I or D to be able to use modus ponens on line 7. I or D. Well, notice we have D in line 2, and we can simplify line 2 straight off and simply add the I to it. If we know D, then we certainly know D or I, so that's how we're going to get the antecedent. We simplify line 2 and get D. We add, we want to add the I, because we're trying to generate this. So 8 addition. Notice we need then to commute the position of D and I to get a line that looks like I or D. And now we have the antecedent of the conditional on line 7, so modus ponens is invoked, and we get not E, our answer, and cite line 7 and line 10, modus ponens. Okay, well, I hope as we have been doing a number of these problems, things have been getting more and more familiar to you. Remember that by the time you get up to Unit 12, you will have had to memorize all of the rules. So be sure that you pay attention to the structure of the rule. And, of course, doing the problems, I think, helps you to memorize those. Here's one last problem before we do a translation. This is an interesting one. Here, again, we're trying to get a disjunction. Remember, we could generate a disjunction if we could get either of the disjuncts separately and then simply add the other. But notice, if you look at the premises here, it's not clear that you're going to be able to do that, because both the C and the F are disjoined to other things, and we can't just drop them off. And we don't have enough material here in 3 to work with to be able to isolate C and F by itself. So we're going to need to do some maneuvering, some replacement of lines 1 and 2. Notice that the C and the F occur as disjuncts of disjunctions, but the other disjunct involved are both negations. This, both the style of line 2 and 3, line 2 and 1 should bring to mind the replacement rule of implication. Remember, not P or Q is the same. It's equivalent to P hooks Q. So applying this replacement rule to both 1 and 2, we can see we could get a line that said S hooks C and a line that said T hooks F in accord with this equivalence rule. How's that going to help? Well, maybe we can do constructive dilemma, because we will then have two conditionals whose consequence are the two elements we're looking for. Let's try that. We don't yet have the full strategy worked out. Let's fill out those couple of steps and see where we are. So I'm suggesting that we go to a line that looks like not S or C first. That's line 1, simple commuting. Line 5 would be similarly not T or F. And now notice both of these lines are the same form as this side of the implication rule. So that means that we can replace them with lines that are conditionals. Those conditionals would be then S hooks C, we cite line 4, and implication, and T hooks F, citing line 5, and implication. And now in order to do constructive dilemma, of course, we need both of these conditionals on a single line. So 8 would be S hooks C and T hooks F. And that's simply 6 and 7 conjunction. Now the question is, to do constructive dilemma on 8, what do you need? You need another line that is S or T, the disjunction of the two antecedents. Look at line 3. Can line 3 be manipulated in any way to give us S or T? Well, the thing to notice about line 3 is that it's a combination of a disjunction and a conjunction. And when you have a situation like this, the rule that applies to that style of sentence is distribution. Remember, don't be confused between distribution and associativity. You can associate only if the line contains a repetition of the same connective, and you can distribute only if you have two different connectives, the disjunction and conjunction. 3, if distributed, would give us S or T and S or L. And remember, the S or T was what we were looking for. So let's do that line. That looks like a good line to do. We cite line 3 and distribution. And now we simplify and just end up with the left-hand side of 9, the S or T. And now we have line 9. We have line 8, both of which are the two parts of the constructive dilemma rule, which allows us to infer C or F from line 8 and 10, constructive dilemma. And that's our answer. Again, as I warned you in Unit 10, constructive dilemma, at least for me, is the hardest rule to see. So always be on the lookout for it. When you see a disjunction is your goal sentence or the conclusion, make sure that you ask yourself first, can I get either of the disjuncts and simply add the other? And if the answer seems to be no, or it looks like it's too hard to do, then always think of the alternative of constructive dilemma. Okay, now we're going to translate an English argument and then do the deduction on the symbolized form of the argument to show that the argument's valid. And here it is. If Bob is an atheist, then God will damn him. But Frank is a born-again Christian only if nuns speak in tongues. It's false that both God will damn Bob and that nuns speak in tongues. Therefore, it's false that both Bob is an atheist and Frank is a born-again Christian. Pretty complex stuff, but remember, we just go step by step, looking at each premise, figuring out what the main connective is, identifying the conclusion, and perhaps things won't be so bad. Therefore indicates the conclusion, and so we know that we have one complex premise here and another complex premise, only two premises, with a complex conclusion. Now let's go look at the first premise here. What is its main connective? If Bob is an atheist, then God will damn him, but Frank is a born-again Christian only if nuns speak in tongues. Very complex. Notice the main break in the sentence seems to be this but. If you look at the first part, that's a conditional, and that conditional ends here at the comma. And it is linked by the connective and, basically, to another conditional, a conditional that is stated in English in terms of the only if. So we need to translate both sides of this premise and simply conjoin them together. We've got first to assign letters. If Bob is an atheist, let's let B be Bob is an atheist. Let G be God damns Bob. Let F be that Frank is a born-again Christian. And let N be that nuns speak in tongues. So our first premise would look like this. If Bob is an atheist, then God will damn him. Bracket that off. And conjoin it. Remember, but means the same logically as and. Conjoin it to this other conditional. This is, in effect, F only if N. And remember from Unit 8, that gets symbolized F hooks N. So there's our translation for the first premise. Now, it is false that both God will damn Bob and that nuns speak in tongues. You may be a little confused about this because we have an operator here, a tilde, that stands in front of the whole sentence. Notice that both God will damn Bob and that nuns speak in tongues is itself a perfectly fine complex sentence, and then we simply have negated it. So when you translate these, don't get confused by the it is false that. Just tack it on when you're done translating the positive version of the sentence. Ignore the it is false that for a moment, and let's just translate both God will damn Bob and nuns speak in tongues. Well, God will damn Bob, remember, is G, and nuns speak in tongues is N, and we want to say that both God will damn Bob and nuns speak in tongues. And now to complete the sentence, we want to negate it. We want to say that this is false. And so we put the tilde on the outside of the parentheses operating on the whole thing. There are our two premises now, and how do we translate the conclusion? Same situation here as with the other premise. It is false that, so we know we could just put that right here. And now what's inside? What are we operating on? Both Bob is an atheist, and remember, Bob is an atheist is B, and Frank is a born-again Christian, and that is F. So there's our translation. Now we have to look at the conclusion and see how we're going to get it from the premises. And we notice straight off that since we have this tilde on the outside, it may be of value to think to yourself, well, that is equivalent to not B or not F. And we therefore are looking at finding a disjunction So now we looked at the premises here and find out how we're going to get to that disjunction. Well, let's note what we've got here. We've got the B and the F in the antecedent of two conditionals. But what we're hunting for is not B or not F. Since it's a disjunction here, we may well want to think about constructive dilemma once more. But notice that one is not in quite the right form for constructive dilemma that would generate not B or not F. What we'd have to do is transpose these two conditionals. The replacement rule of transposition, you'll remember, allows us to go into these lines and alter the two conditionals by inverting the position of the antecedent and consequent as long as we negate each of those. In other words, the B hooks G becomes not G hooks not B, and similarly not N hooks not F is equivalent to F hooks N. And we would cite line 1 here, transposition. Now why we're going to do that is that line 2, you'll notice, is equivalent to not G or not N by De Morgan. Let's write that down. Not G or not N. And we cite line 2, De Morgan. And now, if you compare 3 and 4, you'll see that you've got two lines that we've generated that are in the right form for constructive dilemma. And the answer then, if you apply constructive dilemma on 3 and 4, is going to be not B or not F, which is what we were in effect looking for. So we can put not B or not F on line 5, cite 3 and 4, constructive dilemma, and we're just about done. All we need to do then is change the shape of line 5 so that it's exactly what the conclusion asks for. And we do that. Line 6 will be not on the outside of the parentheses, B and F. And we cite line 5, De Morgan's rule. And that was what we were looking for. So there we are. We've started to learn how to do these English translations. And I'll remind you that the last two units of the course, 12 and 13, are simply building up on what we've now already learned. And in fact, it becomes easier because in each of those units, a certain strategy, conditional proof in the one case, indirect proof in the other, takes our normal deductions and makes them considerably simpler. So you'll have something to look forward to. See you then.